Hi everyone. Are we live? Yes, we are
Yes,
live. All right. Hey Chuck, how are you?
I'm good, Alex. It's all right. This seems like an early Twitch stream for me. I've never been on Twitch this early in my life. It's awkward doing it, like having it be part of the job instead of just something for fun.
Yeah, it's good. It's good. You still have to do it, like get to do it
Mm-hmm.
even though it's fun. So, yeah, it's nice.
Awesome.
What time is it for you?
It's 9:30,
Okay. So
so
you're an hour earlier than me.
yeah, we're in Central. I'm in Central,
Yeah, yeah.
so yeah, it's a little early.
Yeah. All right. So, are there any people joining? Please send us a message in the chat so we can see you. I see there are people, but I don't see anything in the chat. So, feel free to tell us where you're coming from. What time is it for you? Is it too early? Is it too late? Um, and are you excited for doing large binary files? Chuck was telling me a
Yeah,
little bit about it.
I know it's a really exciting topic.
All right, we're getting people. Hi, Beth. Hi, BJ. Hello, hello. Okay, we're getting people.
Hey, everybody.
Hello. Sweet. All right, someone from India.
Awesome.
And someone is saying, thanks, Alex and Chuck, for doing this early in the day.
Hey, Srini.
All right, awesome. Someone from Pakistan. Oops, Pakistan. Awesome. A
Right.
lot of people.
Yeah.
So, a lot of
Cool.
people are excited about doing large
Large
binary
files.
files.
I never knew. I never knew there'd be so much interest. Cool.
Alrighty.
Well, I guess we
So,
should get into it, right?
yeah, for sure.
Let's get going. And I know this is a bit of a no-no, but I am going to start with some slideware. Please forgive me. I'll try and make it brief, and then we'll get into Studio and just have some open discussion. I'm going to kind of run through a mental process or the path to getting to this solution and why we needed it. But I just want to use some slides to just sort of set some background and level set a little bit of talk to me like I'm 5 info, just to make sure we're all on the same page. So we can go ahead and get into that. I am going to share this screen. And I will share everything. Hopefully that's going to work. There we go. My bad. All right.
Got it.
There we go. Perfect. Let's get rid of this. Sweet. All right. Processing large binary files with MuleSoft. I'm Chuck Christus, as you can tell from my name's before. And I just wanted to start with a little bit of level setting, like I said. So background, what are we doing here? Why do we care about streaming these large files, right? Mule already does streaming. So what's the big deal, right? Well, there's a gotcha on that, which is Mule can stream large structured files. And I'm going to get into structured versus unstructured. It's sort of from the Mule POV. Obviously, binary content has a structure, right? But from Mule's point of view, there are sort of structured things that we understand and unstructured things that we don't. We'll cover that a bit more later. But the reality is, this is a frequent customer ask. In their mind, files are files. So they may be doing workloads where they're streaming big, data sets from the mainframe and bring that over and doing batch processing or something like that. And so they're like, well, I already know I can send, a 2 gigabyte file through Mule. What's the problem? Let's send these big image files. So let's send these archives through Mule because we want to do a data migration. And then guess what? The customer discovers, new and exciting ways to blow up their heap when they do that. And then we get a call. And like I said, so some of those common use cases are ingestion of large file archives, so zips, tar.gzs, ISOs, processing of large images. So this could be data sets for like machine vision, GIS, so large geographic images, or even just publishing, a very large TIFF or a bitmap. Typically, these are uncompressed or lossless compression image files. These aren't like JPEGs, right? We're talking large data sets. There might be processing attachments. So email limits attachment size. So some people want to implement a way to get around that and send a large file as like a link that can be embedded in an email. And so that might be a process where Mule is involved. Large amounts of form data, PDFs, right? Or data migration use cases such as a legacy backend storage system to a modern, or like an M&A, merger and acquisition, where you need to bring a bunch of content in from, the acquisition into the primary target. So let's talk about structured versus unstructured. And this really is, like I said, this is from the viewpoint of MuleSoft. Obviously, a bitmap file has a structure, otherwise we wouldn't be able to parse it as bitmap, and an MPEG file has a structure, a zip file has a structure. But for Mule, it needs to have a very clear and standardized format. There's only a couple things that we know that will make it easy to parse into chunks. That's how we stream it. We essentially split it at like a record boundary because we know that structure. We understand that structure. And another requirement to be considered sort of the structured document and be stream capable is, if you're working with DataWeave, you need to be able to process each chunk or unit of work in an idempotent fashion, meaning chunk A cannot refer to chunk B. It needs to be any transformation or anything else you're doing needs to be completely contained to a single unit of work or a single chunk. You can't refer to things outside of that, and you can't refer to the chunk itself multiple times. Like, you cannot go back in time. You read it once, you don't get to go back and read it again and transform it a second time. So there's a lot of requirements really to get something to stream in MuleSoft. And we support that for a couple formats. We support it for CSV, we support JSON arrays, and we support XML collections. And again, if you think about it, that makes sense because they're well structured, there are clear boundaries, and you can read or parse them one chunk at a time sequentially to be able to run through. So just a little bit of, this is a talk to me like I'm 5 portion. Here's the CSV examples just to kind of show how Mule views these things. There's a little hidden part of this, which is there are new lines, right? It's comma separated values, but there are new lines at the end of the line. Those are our record separators. We also know in the structure for CSV that that first record is going to be our header, at least it should be typically. And once we know that, and we know the record separator, well, we can look at the rest of the file as individual data records or chunks. Again, I'm going to use that word a lot. And so we can split the CSV apart and we can process it. We can stream it through. We can do DataWeave transformation on each one of these rows of data, essentially, as long as we follow the rules and don't refer to anything else. And we're good to go. And if this is, 500K CSV, or 500 meg, or a 5 gig CSV, it's all going to be the same. Our record size, or the amount of memory we need in the heap to process this, give or take, is going to be the size of a record. So that's great. We can be super efficient. The problem comes when we move into binary data. And to Mule, this doesn't look anything at all like a CSV or like an array from JSON. It's just bytes. So even though there is a structure right now in Mule, it's unaware of how to parse that. It doesn't know that this is a zip. It doesn't know anything. It just sees a bunch of bytes. So when we try and split this into a record, we're not really going to get anywhere. Mule doesn't know what to do. It thinks that it's essentially all one big chunk, or it will simply error out and not allow you to build. You might get linting errors or syntax errors in DataWeave trying to process it, or when you run the flow, it's just going to bomb out. So again, structured versus unstructured, this is purely from a MuleSoft point of view. I think we beat that to death, but at least we're all on the same page. So for the sake of what I'm going to kind of demo and walk through today, I want to set up just a very high level scenario. We'll see, it's very few requirements, but just so that we have a baseline. Excuse me. We're working for Mule Corp, let's say, and we have pretty simple requirements. We're just being asked to ingest and store files into a backend storage system. In this case, it's going to be SharePoint. And then at the end of that, we need to provide a link to be embedded into a front-end system. And in this case, that's going to be Salesforce. So we have a process where either a user or some other process is uploading a large piece of content. We need to get that into this backend system and be able to link it to a front-end system. Because again, our front-end system, this is a real common use case where whether it's email, whether it's Salesforce or whatever, it's not necessarily a place we want to be storing that large bulk content. It's better to just present a link to it in the UI and say, here, if you need this or you need to download it or you need to work on it, go get it here. So that's really kind of our use case. That should be no problem, right? Of course, it's going to be a problem, but we'll get to that. And so just a super loose, again, talk to me like a 5 diagram. We have a user or a process through some sort of web front end that's uploading this file. We're going to take that into Mule, put it on SharePoint. Once SharePoint says that file is good, it's going to send us back a download link. We're going to take that link and embed it in Salesforce. And spoiler, we're not actually doing that last part. We're really just focusing on the file processing part. But theater of the mind, imagine, if you will, that the ultimate end of this process is forwarding that link on to another system for more processing. So how do we do this, right? Let's get out of the slides and let's get into some actual work. Here I have a SharePoint site. This is just a folder where things are going to land. So that's purely here just to show that things get to Salesforce. I do have an OAuth tab over here that I'm going to have to work on and use in a minute to authorize this flow. But that's it. So, okay, I know my scenario. I know what I need to do. I need to bring in a large file, and it's going to be binary content. In this case, it's going to be images, let's say, or a zip file. The first thing I would do, and you can see I already have this flow built, but it's like, okay, well, I need to work with SharePoint. So I'm going to go to Exchange, and I'm going to look for a SharePoint connector. And here it is, and I'm going to go ahead and add that to my project. Great. Let's take a look at what SharePoint provides. Well, right here at the top, we've got file add. That sounds like exactly what I want to do. So I'm going to go ahead and build this really simple flow that does that. And there's a couple things, that you want to do if you're aware of streaming in Mule when you're setting this up. It's important that you set your MIME type. And then there's also a parameter that you would normally set here. And that would be streaming, and you would set it to true. Go ahead and add that parameter. Again, I'm kind of jumping to the end. I'm going to be doing this a lot. There's one problem with that. Remember where I said Mule only handles structured data for streaming? I have this set. I know I'm getting a binary input stream. So my MIME type is set to application.catstream. If this is not set to CSV, XML, or JSON, adding this parameter doesn't do a thing. It doesn't prime anything down the pipe for streaming any differently than you just get with the default under advanced. I'll go there in a moment. This is meaningless. So if you're worried about bringing in this content and streaming it, and it's binary content, you don't need to bother with this. If you go through Mule docs and stuff, you'll see that they say you need to set a parameter and it needs to be streaming as true. I can confirm that plays no part. It's not going to be honored if this MIME type is not one of those 3 supported types. In this case, if we go down to advanced, we have our streaming strategy. That's a repeatable file store stream. That's fine. We could probably do this in memory as well. This is sort of the default, and the default should be fine for this. It would be something which we can tune. So that's really all you have to worry about. Just make sure that you have, streaming mode set here in advanced, and you should be good. But know that setting a parameter in MIME type isn't going to help you here. Man, sorry, my throat is killing me. it's gonna be a long stream if this keeps up. So we have our listener. We're going to bring in that file. I've brought my file add over because that's exactly what I want to do. I've set up my SharePoint connector. I'm not going to make you suffer through that. And then we're just sort of logging the result of that and sending that message back. In this case, let's assume that message is going to have the download URL. And let's go ahead and kick this off. And you can see I've got multiple different heap sizes here. I'm going to use a 512 meg heap. I'm trying to do this in a pretty small size. I'm trying to, replicate sort of the parameters and performance we would get. Well, mostly the performance we would get from, a fractional core worker in Cloud Hub, where you're not going to get a lot of memory. You're not going to get a ton of CPU. So we're going to let this build so that I can OAuth and get a token. And while that's building, I'm just using Postman. So Postman's going to be my stand-in for my web front end where I would be sending this file. I've set this up with this TIFF file. This TIFF file is 50 megabytes. Not tiny, not huge, but big enough that it could cause some problems. And so we're just going to submit this in once everything gets started. And we're going to try and add that file to SharePoint. And hopefully that all works. There's going to be a lot of stopping and starting. So this is going to be somewhat slow. All right, that started. So I'm going to OAuth here really quick and get a token for our org. Awesome. All right, so now this flow is ready. We've solved everything that's been asked of us, right? I'm going to push this file. We see it come in. We see that our payload is indeed binary data over here, right? This is, MuleSoft doesn't know what to do with this, but the SharePoint, file add block certainly does. So let's just go ahead and let that run. I'm hoping this doesn't, I might be a little bit limited on network bandwidth. So I'm hoping this doesn't take too long to upload some of this stuff. It is only 50 meg, but I know my upstream is great. That wasn't too bad. All right, so we've uploaded SharePoint. Before we run through the rest of our Mule flow, let's actually verify that that happened. We come over here, sweet. We see our test.tiff file. It did indeed come over. And that looks great, right? So we can log our result. You see that we get, a JSON response from SharePoint here. And we'll send that back to Postman. And everything looks great. That was easy. So problem solved, right? Well, yes, because a 50 meg file can actually fit pretty well into our 512 meg heap. So if we actually start monitoring that, we'll see that, we're not using much of that heap. We're using about 200 meg currently. So let's run a slightly larger file through there and see what happens. In this case, I'm just going to jump because, like I said, I don't trust my upload speeds too much. But let's go to this 270 megabyte file. And we'll call that just test.dat. It's just a data file. So we're going to send that through. Here we go. We've got it. So this time we're actually going to watch the heap while we go. All right, we're uploading. And if we keep our eye on this heap, what we're going to see generally is good. It seems like there's been at least some implementation in the SharePoint connector to allow garbage collection to happen. So we're ramping up. We're getting right to that peak. But we GC and we're okay. Nothing crashes. We're going to kind of ramp back up again. And we should see another GC. This is going to take a little while. I'm actually just going to clear this console here so we can see any output fresh. We'll keep an eye on our heap. So this looks good. We've obviously sending that file is consuming more heat than we have, but we can GC. There we go. There's another one. Now that wasn't quite as effective of a GC. But that's not our real issue. Great, I was waiting for this. I just didn't know how long it was going to take. Our real issue is that the file add block is only going to allow us to send essentially 250 megabyte files. So while it is effectively using heap, we can't really know that it would blow up or not, because at least at 512 megabytes, by the time we've sent enough of that file for SharePoint to kick it back to us, we've been able to GC. But it looks, we can see a pattern here where we started here, we ramp up, we GC to a higher baseline level, we ramp up again in GC to a higher baseline level. So I suspect even if SharePoint didn't stop us, we'd be in trouble before too long anyway. But here's the reality. The file add block isn't going to work for more than 250 bytes. They give you a little bit of leeway. That's why I had to send 270. They'll let you go a little over 250, but it's meant to be a 250 megabyte block. So we didn't blow up the heap, but we did blow up SharePoint. Now, the great thing with this block is, for whatever reason, and this is how I know that whatever strategy they're using probably wouldn't GC properly if SharePoint could accept larger files. Let's send a 500 meg file. I know SharePoint won't take this, but I want to see what's going to happen to the connector. So we'll call this, since it's a zip file, it's not really going to matter because it's not going to send, but we wanted to name it icons.zip. Let's send that. And let me just clear this so we can see everything. Right, this happens. Our heap, right, there was our big GC. So we're kind of back to our baseline of that, 150 to 200 megabytes. We've got our file. Let's send that to SharePoint. And let's watch what happens with a 500 megabyte file. We spike up. Oh, look, things went way down. Like really quick. That's because we're out of memory. So even using that same block, that works just fine for a 50 meg file. It is perfectly fine with a file slightly larger than what SharePoint can accept, that 270 meg file. But if we were to just randomly, if a user was just randomly to submit a 300 meg or a 500 meg file to that block, it doesn't run like the 270 meg file. It doesn't run, hit the heap cap, GC, and keep going until SharePoint says, hey, I can see that you've sent, more than my limit of files. I know you got more to send. I won't accept it. It just blows up the heap. Your Mule runtime is just dead at this point. So we know that this block, or the SharePoint connector as it stands, isn't going to work for us. And for better or worse, you'll see this with a lot of our connectors, things like Dropbox or G Drive or whatever. They all support sort of a basic add a file. And almost all of them have a limit like this of around 250 megabytes. Some may be better with managing heap than others. It's going to be totally implementation dependent. But there's the danger of something like this happening. And ultimately, 250 meg is not what I would consider large. It's not small, but it's not large. We want to be able to send a gig or more through that 512 meg heap. So this isn't going to cut it. And in fact, it can be, dangerous to use this way. Now, looking through the rest of this connector, there's really nothing else offered from the SharePoint connector that is that's going to get us past this limit. And so now we get to the meat of the matter of, well, then what do we do? How do we solve this? Because I can't use the out-of-the-box connector, but I have to be able to accept these files and get them to SharePoint. And I know SharePoint can handle large files, so there must be another way to get stuff in. And there is. And essentially, it's the Microsoft Graph API for OneDrive, which ultimately backends SharePoint. And within that, unfortunately, I don't have a screen of all the things I got pictures of and stuff. I don't have a screen cap of that. But if you go and look up Google Microsoft Graph API, what you'll see, and this is pretty common among all cloud storage vendors, is they have what's called an upload session API. And the way that works is, I think I have something kind of showing this. This is really very low fidelity, but it allows you to, after you've chunked the file, it allows you to start an upload session and then send those chunks until you're done. And then the end, the API endpoint, in this case SharePoint, but it could be Google Drive, it could be Dropbox, it could be whatever, will reassemble those bytes into the actual file. And so we want to leverage that because that's what's going to break that 250 megabyte barrier. We have to use the in Microsoft's case, the Graph API, but what you want to look for if you need to do this is an upload session API. So, all right, let's clear out SharePoint. So how do we implement against an upload session API? I actually need to go back and close this project, otherwise things get messed up. So we're going to get rid of that, and we're going to move over to this project. The first instinct I had when I needed to solve this problem was, well, I'll use DataWeave, right? In that world, before I knew that unstructured binary data wasn't going to be streamable in DataWeave, I spent a lot of time trying to play with that. And there's a couple things that you'll find. I'm just going to bring in a transformation here, purely just as a sketch pad. What you'll see is a lot of documentation, kind of like what I was showing, where it's going to tell you to set the input to this block to, you have to specify the MIME type and you have to specify streaming is true when it comes in. So I did that, right? I came into my listener and I set that up just like we showed before. I came into MIME type, I added that parameter, and then I created a transform, and I was like, well, to do this, my input is going to be application sort of octet, octet stream. How do I chop that up? What is that going to look like? And there's a couple things that you'll find. I'm literally just going to copy paste. It's a pattern that I came across a lot in sort of Googling around and trying to find help on this, which it looks like this. And so where you end up, because I ended up here too, is if you dig around in the DataWeave libraries, you'll find the core arrays library. And that has a function called divide by, which kind of does exactly what the name says. It takes an array of X size, and you give it essentially the number of items you want to split that, like chunk that into. So I want like 5 items in each sort of chunk. Divide by will do that, and then it will give me the remainder. If there's like 3 or 2 at the end, it'll give me one last array item, essentially as like the grouping of those last 2 or 3 items. Whatever the remainder from your chunk size is. And I was like, cool, I'll do exactly this. I'll set them, I know that the payload is binary. I can split that. Essentially, I need to split it into X number of bytes. These graph or these upload session APIs usually have they'll accept 100 megabytes maximum per chunk, or 200 megabytes or 250, whatever it may be. They'll have a limit, and it's like, okay, I want to split to some, something within that region. Maybe it's 10 megabytes, maybe it's 100 megabytes. So I need to slice up that binary payload into individual bytes, and we do that by using a split by on essentially nothing, saying split every character. So split every individual byte. And then I take each of those bytes. So split by is going to give me an array of each of those bytes, essentially. I'm going to divide that by whatever I want. If it's 10 megabyte, 10 megabytes, I would put the value for 10 megabytes there, the number of bytes. And then you map that to an output, and then you join essentially all of those array elements at the end here back together. So what you should end up with at the end of this DataWeave, if all goes well, is an array of byte arrays, right? Array of array. And each of those byte arrays will be of chunk size that I want to send to my upload session. Here's the thing, this doesn't really work. I never really got it to work. I could never get consistent output, even if it did work. And whatever I could get out of it was somewhat unrecognizable downstream as far as being able to process it in a loop to be able to do it. So this is a journey. This is the first place I thought to go. It doesn't work is the bottom line. I also explored, many other ways of looking at things like we have stream capable as an annotation that you can add. And I think you need to add an input for this as well. I'm kind of going from payload, and then you have to do the MIME type. So in this case, it's like octet stream, right? If there's like a dash in that, but I think that's right. So you do that, and we have our preamble, and you'll see right away there's like one issue found. Ooh, that's the body. So let's just do like payload here. I just want to have it go. So this isn't throwing an error, but much like previously with setting the stream equals true or stream equals true parameter, this can all look correct, but it will not stream. If you run a 500 megabyte file through this 512 meg heap JVM, it just blows up. You run out of memory. So no matter how you slice it, if we do all that same stuff, if we split that payload, split by whatever payload as binary, and so on, we do the rest, and we do the arrays divide by, everything just blows up anyway. So none of these DataWeave explorations really bore fruit. And even talking internally to the team at MuleSoft, no one could give me DataWeave that would do this with a binary file. Everybody had stuff for CSVs or XML, but we just couldn't get there with binary content. So then I thought, okay, well, I know we can run Java. It's not pretty, right? It's not pure low code, no code Mule, but maybe there's a solution there. And as it turns out, I guess I put something to clear that out. I'm just going to get rid of this so we don't have a broken project. As it turns out, Java is kind of the key to all of this. So that was the breakthrough, was this invoke static, or you can just instantiate a class and invoke it, but invoke static makes it a single block. I started looking at that, and the big question was, is there a way in a Java element to ingest the incoming payload as a stream? And as it turns out, so this is my binary chunker code in Java. This is pretty simple. This is really the guts of it. You can actually define a method signature with an input stream as your input, and assuming you have a streamable block in front of it, so anything like an HTTP listener or a file read, or anything that can sort of ingest and stream out, get you a binary sort of object stream out, you'll be able to pull into your Java code as an input stream, which is great because now we have control. We can ensure, given a specific chunk size, that we're never going to consume more memory than that while we're processing this. So this is just simple code. While we're reading from that input stream, we have our chunk size, right? We read that chunk. The next question was, how do I stream out of this? I know I can stream in now, but how can I stream out? And I'm going to jump to the end. I couldn't find a way to do it. I tried many ways of spitting out Java objects or Java arrays, again, like that byte array that I was trying to get out of DataWeave. And nothing downstream seemed to work, or I would chunk just fine in Java. And then anything I sent that list to downstream would not process it one block at a time. It would try to read the whole thing into memory, and we would blow up heap again. So I could get data in, but I couldn't get data out. And then there was sort of a moment of reflection where I thought, well, if I go back to our HTTP listener, or I go back to any of our components that have sort of stream capabilities, and I was looking through this, and it's like repeatable file store stream. Oh, it's just writing to disk, and then there's a mechanism behind the scenes that's reading from disk to do the streaming, right? That way, once we've written it to disk, it doesn't need to be in memory anymore. We can pull from it as we need from the disk. So what if we just write to disk? And so that's what I did. That's the big revelation. Surprise. We read in that input stream, and then right here, we're creating chunk files, as I call them. So instead of one big file to read out from, though you could certainly write Java code to do that if you wrote to disk, instead, I'm just making files on disk that are of chunk size. That way, any subsequent operation working on one of those files will never need to read in more than the chunk size amount to RAM, right? So that's the breakthrough. That's how we can manage our heap size. That's how we can allow the JVM to garbage collect. And in this case, I'm just sort of generating I generate a UUID to keep the chunks unique. If you don't pass in a path here, I'm writing to the Mule temp directory just by default. So you don't even have to think about a path or anything. It's going to go there, and it's an area on disk that'll get cleaned up eventually. And I just numerically order the chunks so that we can send them in order, and that's it. And we write them out. Any to chunk size, any remainder gets written to the final file. And great. So now, if we come back to this flow, if we run through this, and I'm going to run through this with actually sending a file in a moment, but we'll do a quick run through on paper, as it were. The first thing we do, aside from saving the file name and the chunk size, which is this first step, is actually chunk the file. So we're feeding that stream before we get anywhere else into Java and writing it to disk in whatever those chunk size amounts are. This is an important step. So following that, because I'm not returning data directly as a payload, I do return content, but I'm putting it into a variable. The payload still actually contains the binary data. So if you don't take action to null it out, and I don't know if this may not be familiar to folks, but you literally, this is how you null a value using DataWeave. I am setting the payload here explicitly to null. Otherwise, everything I just did in this Java block would be pointless. The payload would carry through, and the entire payload by anything that was looking at it would get read into memory and would blow up the heap. So it might not seem important, but this is a really important step. The rest of this is starting to set up our upload session with SharePoint. So in here, I'm going to make a JWT request. I'm going to get a token, essentially. I'm going to store that token because we need that for all of our subsequent requests. I'm going to make a request to the Graph API to begin that upload session. And this is kind of a convoluted path that you have to pass. You can see it's very long. I'm constructing it from various items. You have to kind of get a lot of IDs to do this. You need to know like your SharePoint org. You need to know the top level folder within that SharePoint org. You need the ID for that. You need any subsequent folders underneath that. You need to give it a file name. You need to give everything. So you have to construct all that. But the important part here is way at the end of that, there's this create upload session. So that's ultimately what we're kicking off here is going, I'm about to send you a whole bunch of data. So get ready, right? And part of that is also telling it how large the file itself is. So, and I think that goes in a header on this request. Sorry, my mouse is acting up on me there. I believe that goes into the headers. No, it's just open. Okay, so somewhere in here we tell it the size. I think it. Oh, you know what? It's on the first request. Sorry, my bad. Once we get into the loop, getting ahead of myself, that's where we send the size. So after we've begun that upload session, we're going to get a URL back. And that URL is where we upload our chunks. So that's uniquely generated. It's like a huge, really obfuscated URL. It's not likely anyone else is going to get your URL or figure it out. And then we need to set up some essentially session variables. So we need to keep track of how many bytes we've sent. And this value called range start. Again, these are sort of SharePoint unique, but every other system that works like this is going to have similar values. You need to tell it the range of bytes. So you need to tell it like where you're starting in the file. If I'm starting at byte 10, right? That's going to be that's where the endpoint system is going to place the payload that I'm sending it. It's going to start at byte 10, and then I have to tell it how many bytes to be expecting. So I have to update the range on each iteration. So here I'm storing those variables. The reason it's important to have them here is you need to store those variables outside the scope of your loop. If you set these up in your loop and then increment them, as soon as that iteration is done, that context goes away, and any iteration or incrementing of that the bytes read or the range start is going to get lost. So you have to establish, right? It's just a scope. So we have to establish these as sort of in the global scope, and then we update them over here within our loop. So we do that setup. Since we've conveniently chunked our big file into our big incoming file into a bunch of little small files locally, we start that loop for our upload session by just reading one of those chunks. We store some attributes about that because we need to know the size of that chunk and everything so that we can establish our ranges. We upload that to our session URL. So here's that session upload URL that we stored from earlier, and it's just a binary payload dump. And here, I believe, is in the headers where we're setting those ranges. So let me expand that a little bit. So we need to tell it the content length. So that's the size of our current chunk. And then the content range, which is where we use those session variables, right? So our range start, and then down here, the file size of the chunk, essentially, we're adding that. So we're telling the begin and the end of our range in the headers. Assuming that's successful, we upload those session variables. So we want to move our index, our counter forward for that next range that we're going to send. And then we delete that chunk. Now, there's not real serious error handling in here, but in theory, you could do some checkpoint restart. You would know, you could keep track of what chunk you're on. And since they're still on disk, you could recover from an error. Let's say this, this upload failed. You can get in there and restart from the last chunk. You can calculate the range offsets and resend it. We're flying by the seat of our pants here to keep this simple. And then ideally, when all is said and done, we get a download URL from that we're going to return back. And that's what we would link in our Salesforce app. So that was a lot of talking. Let's just see this in action. We're going to go back with another 512 meg heap, and we're going to keep track of how that heap is managed. I know that was probably a brain-numbing amount of walking through this, but just trying to explain the process as well as possible. If there are any questions, please jump in. This is kind of the star of the show, so once this is over, we got nothing but time. We'll probably have about 10 minutes or so, I think, for questions, if there are any. All right, so we're started. We have a different endpoint here. So here, this is our graph upload endpoint. And just for fun, let's upload that original TIFF file with a chunk size of 10 megabytes. So yeah, I forgot to put, it'd been good to put a breakpoint in here. But let's go through this. So right now you can see it's uploading and there's our link. All right, so that's done. I'm going to go back here since I didn't put a breakpoint. But what you'll see is this is where we hit the Java code and we're writing out those chunk files. So here's our chunk 1, chunk 2, chunk 3. I know that's a 50 odd megabyte file. And I set my chunk size to 10 megabytes. So it makes sense that we get 6 chunks. Here's 10, 20, 30, 40, 50 megabytes, and then whatever's left over. We set up our Graph API. We call it, I'll walk through the next one, at least for one iteration. And then this is where we're sending it, the chunk, and then it comes back and says, here's what I expect next. I expect, from 10 megabytes somewhere to 53 odd megabytes. And so I send the next 10 megabytes and now it goes, okay, now I need from 20 megabytes to 50. So it's telling you what's remaining. You can upload these as long as you do the range start appropriately. You can upload them in any order. Makes sense to just go sequentially. But this is responding to what it needs. This is the last chunk. It has almost everything. Send it, we get that download link back. If we go back to Postman, you can see that we have our newly launched SharePoint URL. If we go to SharePoint, you can see that we have our TIFF file uploaded. So we've done the same thing that we did with the file add block from the SharePoint connector, but we've done it through the Graph API. So once again, now that we know we're going to start sending larger stuff, let's connect to our JVM so we can monitor things. And let's send, since we know 270 megabytes didn't work, let's try and send that. Because if that works, we know we've gotten past our limitations from the connector, and we should be able to send anything we want. Test.dat, let's call this one, or let's call it 270 megabyte. .dat. We're going to send that. And this time we'll walk through a little bit because I just want to show a couple things. So once again, we can see we have our binary payload. We still have 10 megabyte chunks here. Let's just clear this. So here you're going to see we spit out those chunks. So there should be, there we go, boom, 26 of those. So slightly less than 270 megabytes. What I want to show here is we're past the Java code and we're at our null out the payload. If you look at our payload, it's still that binary content. This is why we need to null out the payload. Our Java code writes directly to this variable, this input file variable here. And it's storing things like the path to where the chunks are, how many total chunks. So here you can see this chunk count is 26. And the UUID of those files. So that is the payload from the Java chunking, but it goes into a variable. So if we don't null this out here, we're going to run into problems. So we take that step. Now our payload is null. Great. We're being efficient on our memory usage. We request our JWT. We begin our upload session. Everything is going great. And I'm just going to walk through one iteration of this. We're going to read our first chunk, our 10 megabyte chunk, from the list of files we essentially got back from the Java call. We're storing our attributes. We're uploading that to SharePoint now. Great, we get our response, and this is where SharePoint tells us our expected range. Out of 269.999 megabytes, we have the first 10, so it needs everything from that first 10 megabytes onward. We log it here just so we can see that, and then we delete that chunk and clean it up, and then we go again. Now, I'm just going to let that run, and we can watch the heap now. And what you'll see is that sort of standard staggered stair step that we expect. It's going to trend up towards, getting towards utilizing the full heap, and then we're going to see a GC, and then ramp back up. What we're hoping to see when this is all said and done is no error from SharePoint. and a 270 megabyte file added to SharePoint. So we can keep track of about where we're at. So we've uploaded 120, 130 megabytes now, 140. Network bandwidth actually isn't that bad. 70. So again, we've got this sort of nice stair step up and down. So everything's looking great with our heap utilization. Granted, we should be able to fit a 270 megabyte file through there, perhaps without crashing, but and since we're kind of running short on time, we're just going to go for the big guns next. So 260, this is our last chunk. That goes through. You can see we've got our download link here. So that was successful. We just overcame the limitations of the built-in SharePoint connector and all the limitations in the Mule platform around streaming binary data by leveraging one short little Java function and then building a methodology around that using these upload session APIs. So if I look in this file, I think version history is what I want, oddly enough. So that shows our file size. So it is slightly larger than that 250 megabyte limit, but we got it up there, no errors. But that's great. 250, 270 megabytes and a 512 meg heap isn't that impressive. So let's just go for the big guns. And we'll send an ISO. We'll send a 1 gig ISO. That absolutely won't fit in a 512 meg heap size if we were not streaming it correctly or processing it appropriately in chunks. So we're going to change this to 1 gigabyte .iso. I'm just going to go ahead and kick it off and hit our debug, but I'm just going to let it run. And we'll watch that process. And while that goes, so boom, we're going to make a lot of chunks. I probably should have made a larger chunk size for that. But boom, there's our 97 chunks. And we're starting to upload it now. So while that's going, if there are questions, great. I do see some questions. So we'll get to those. I'm just going to move over so we can watch the heap here, because now we know if this isn't working, we're going to exceed our heap size. So let's just keep an eye on that. How does the temp chunk storage work in CloudHub? It essentially just works. The way I'm getting the temporary path is it's valid for running locally, and it will find the appropriate path in CloudHub. You do want to check. So there are some sort of space limitations there, an ultimate space limitation, and I should have an answer for that. I don't know the exact size to be fair. That's on me. But I think that's pretty easy to find. What I can tell you is if you use RTF for this, you can be in control of that disk size. You can also connect to a different storage path. You don't have to use the temp. Okay, awesome. So it looks like there was already an answer in there based on that. So you can use temp based on your size. Yeah, that's it. So if we're playing the same binary file, the SFTP, can we use the default streaming? Do you still have to use the Java code for the chunking? If it's raw binary data, you may run into the exact same issues I ran into. Thank you for answering that. 8 gig for 0.1 and 0.2 workers. So you've got a reasonable amount of data to play with, unless you're sending really, really big content. But if you're doing that, you probably need a larger worker anyway. So for the SFTP, you may run into the same issue. The problem really is some of the connectors and some of the flow between blocks for binary data, for better or worse, just isn't necessarily stream capable. It's not aware. And so it's going to attempt to queue up for that next block the whole payload, all the content. You may be able to do a strategy where you immediately write. So you use like a file write block to do the same sort of disk temporary disk holding and then read straight into the SFTP, but you might run into the same limitations. Honestly, it's kind of a, if I'm going to be totally blunt about it, it's like a mildly infuriating what works and what doesn't work. Like what's stream aware and what isn't, because a lot of things are, particularly for structured content in the MuleSoft terminology that we gave earlier, CSV, the JSON arrays. And then there's just like so many things that aren't, or one little piece of the puzzle that isn't, and the whole flow breaks down. So yeah, I don't know if that's a great answer to the SFTP question. It's sort of an it depends. I can't say that I've specifically tested it with this methodology or trying to run it through directly, but I do know that things can get a little touch and go. The good news here is, looking at this, is our heap is looking great, right? We're getting excellent GCs, totally clean. We're pushing double our heap size file through. We're already at 720 meg, 730 meg of that. And we are in no danger of overrunning our heap size. So from that point of view, while I do think this is sort of slightly hacky and cheeky, inserting the Java chunker, it's certainly effective. It's undeniably effective. One thing I do want to say before this wraps up is I will be making a blog about this. It's going to go in a little more detail, and I will be making this project and the code, including the little Java chunker. There's nothing magic in that anybody could write. Like, it's literally just read X bytes and write a file. So there's no magic in it. But I will be releasing this code and this project with that. So you'll be able to do that. It's obviously built for SharePoint, but you can modify it for whatever endpoint you want. I think we're probably pretty close. I should just be watching over here. Yeah, 940. So we're almost there. We've almost sent our gig of data through our 512 meg heap.
Where are you going to upload the code or the posts so people can know?
That's a great question. I think it's going to be through one of the traditional MuleSoft channels. It might be through more than one. I'm not sure just yet. It might be in DZone, I think, is maybe what we're targeting. Yeah, the code will be on GitHub, but that's going to be a link from the blog. The blog content, I've never done a blog here, so I'm still working through that process.
Okay.
But follow, if you want to follow me on LinkedIn, it's just my profile / C Hurstis, CHIRSTIUS, first name, last name. If that's up on screen, I can put a link to that in chat. Let's do that. Because I'll definitely post a link to it there once it's available, if nothing else.
I found it.
Got it.
Yeah.
Awesome. Thank you so much. And so great. So we sent our 1 gig. Just get back to this and finish it out. We have our download link. If we go to SharePoint, we see our 1 gig ISO. Let's just prove it. Version history. All right, slightly less. Still roughly double our heap size, 969 megabytes. And just one last time, this was our 1 gig file upload. Super clean, excellent utilization of the heap, and a really nice GC there at the end when everything was said and done. And that's really it, guys. I'm done babbling at you and talking. I really hope that was interesting and useful. This can be really complicated. It really shouldn't be, but it certainly can be. It was an adventure for me to get through. I found this to be a really good hack. This is something that has been presented to actual customers, and they are building workflows around this. So I can't quite say that it's battle tested just yet, but it's been very well received so far. So that's kind of all I got, unless there are any other questions.
I don't think so.
Cool.
There was just one person earlier asking if 10 gigabytes was gonna work.
It would.
Okay.
It would.
Perfect.
Yeah. The reality is once you've sent something beyond the heap size and you're fine, you can send. I would normally do like a 2 gig send. We just didn't really have the time. I didn't know what my upload speed was going to be, but I think that's it.
All right.
So yeah. So thank you. Thanks everyone for hanging out. And I will follow me on LinkedIn, and we'll have that blog out fairly soon, and you'll be able to access the code directly.
Perfect. Looking forward to it.
Thank you so much, Alex, for hosting this.
Yeah, it was super interesting. I hate that you use Java, but
yeah, I do too. Right? It's like it's a stab to the heart, but like that was the solution. That was it. I couldn't find any other way. And like I said, I worked with the internal team, and it was like,
yeah,
there's no solution. So you make it work.
It is what it is. Yeah.
Yeah. Awesome.
All right. Well, I'm looking forward to your post. Whenever you put it, let me know, and I will also share it in my socials.
Thank you so much.
Oh, there's one more question.
Oh, what is that?
I think they're writing.
Okay.
But yeah, in the meantime, remember to go to twitch.tv/MuleSoft_community so you can follow us there. And as you can see, a lot of our engineers are talking in the Twitch chat sometimes. So that may be better for you if you follow us from there. Also, you can see the schedule, so you can see our future live streams, and all of our previous live streams are recorded there. And you can also get notifications as soon as we are live. So I recommend you follow us on Twitch. Or you can also watch us from LinkedIn and Twitter, but it's going to be a little bit harder to follow the previous live streams. And we're still waiting for the question.
It's a long one. It must be a good question.
Are you good on time, Chuck? Or
I'm good. Yeah.
Okay. Okay. Cool. There it is. I don't understand the question. Can we trigger flow when we play video?
So, like having a live video stream come in as the binary input? Is that what you mean? Like, or are you talking about streaming out?
Video file should be picked up
when the video is played. So I don't know. I don't know that that's a Mule specific thing. If I'm understanding what you're asking correctly, as long as you had a hook to capture the video stream on playback and forward it to this Mule flow, then yes, in theory, that should work. Because from our point of view, at the end of the day, we're just getting that binary payload, that post in the body of that stream of bytes. So if that's a video stream that's coming in and you're able to trickle those bytes in, we would chunk that. It would not be real time. So what would happen is when 10 megabytes or whatever, 100, whatever you set your chunk size to, whenever the chunk size number of bytes came in, the Java code is just going to write that file, and then it's going to be waiting for the next bytes, right? It's going to be looking for it, and the listener is going to be seeing those bytes. So what would happen is you would stream everything in. At the point where the stream ended, you'd have all the chunks for that, and then you could forward it to something else. In the current incarnation, you would not be able to stream in and then stream back out, right? In a real time. You could potentially write something to do that. The current code wouldn't. But that may be something that could be implemented. The hook there, the clever part of that is not so much the Mule side, it's getting that hook to the input stream directly so that you can send it to Mule. I feel like that's the hard part of that. So hopefully that answers the question or helps. It's an, in theory, yes, you could do that, assuming you can get the hook at the start.
All right. Perfect. Well, thank you so much, Chuck. This was super,
Awesome.
super interesting. So really appreciate it.
Yeah, thanks, Alice. Thanks everyone for hanging out. Take care.
All right. Bye bye.
Bye bye.